Hello everyone, good morning. Hope you can see clearly. Today we are going to discuss about question and answers in electricity. One second, within few seconds we will start the class. Good morning, Reena. Sai Nikhil, good morning. Okay, let us see first question here, MCQs. These are MCQs in electricity. Electrical resistivity of a given metallic wire depends upon Sudhir Kumar 5143. Good morning. Electrical resistivity of a given metallic wire depends upon what? It depends on what? Resistivity of a conductor depends on what? Length, thickness, shape, nature of the material. Which of these following electricity will depend? You can type your answer in the chat. I want to know what you are thinking about it. Does it depend on length, thickness, shape, or nature of material? On what it depends? See, we all know resistance depends on length. Resistance of a conductor depends on length. Resistance depends on length. Resistance depends on area of cross section. Resistance depends on thickness. But resistance does not depend, resistivity does not depend on length or any dimension. Resistivity depends only on the nature of the material. Material to material, it will be changed, but it does not depend on length or area of or thickness of the conductor or shape of the conductor. So the first question answer is going to be resistivity does not depend on any first three, depends on only nature of the material. Material to material it will be different. The first question option is D. Option D is correct. Now can you see the second question what it is? Second question, are you trying to find what is second question answer? Second question answer. An electric kettle consumes 1 kilowatt of electric power when operated at 220 volt. A fuse of wire, what rate must be used for it? Good morning. Fuse of wire, what rate must be used for it? So here current, when you want current, what it is given here, power is given and voltage is given. We know the formula, power is equal to voltage into current. P is equal to V into I, we know. So when you want current, current is equal to what? Voltage by power by voltage. Current is equal to power by voltage. So power by voltage, what is power? Power is 1 kilowatt, 1000 watt by voltage is 220 volt. So if you divide it, cancel. Then what happens here? 11, what? 2 11s are 250s are. So what it is? 11 ones are 11 fours are 44. 11 fives are around 4.5. Around 4.5 amperes it is coming. So when it is 4.5 amperes, when it is 4.5 amperes, your fuse must be little more better than this. Means what? More than the given 4.5. So your answer should be 5 amperes. Fuse should be made at the rate of 5 amperes so that it will work. So whenever question comes related to fuse, what you must do, you should find out current till what rate we can keep it. So it is physics, electricity topic. Physics, electricity topic of class 10th. So it is 1 kilowatt by 220 volt. So that what happens? We get 4.5 amperes. 4.5 amperes. When it is 4.5 amperes, we can take little more extra than that. That is 5 amperes. So 5 amperes is the correct answer for this. Question number 3. Good morning, Karthik. Question number 3. You have different circuits and the question is about in the following circuits, heat produced in the resistor or combination of resistors connected to a 12 volt battery will be where it is, how it is. Is it same in all the cases or minimum in case 1, maximum in case 1, maximum in case 3? It is about physics, electricity topic. Okay. Now in these three circuits, you have to decide where heat produced is maximum or minimum. In which circuit it is maximum or minimum, you have to decide. So how do we decide in which circuit it is maximum or minimum? How do we decide? Heat produces depends on the resistance of the conductor and the current in the conductor. So if you want resistance, in the first case it is only 2 ohms. It is 2 ohms. And in the second case it is 4 ohms because they are in series. And the third case it is 1 by 2 plus 1 by 2, it is 1 ohm. If you observe, in the first circuit it is 2 ohms, second circuit 4 ohms, third circuit 1 ohm. And you remember heat formula is, we have one formula like this, V square by R into T or I square RT. So by this we understand resistance is inversely proportional to the heat produced. So this is also important point you have to remember. Heat produced in a conductor is inversely proportional to resistance. So when more resistance is there, less heat will be there. So here in first answer is wrong because it is not same in all the cases, because here resistance is different. Heat produced also depends on the resistance. So in first case, it is not same. First question answer is wrong. Minimum in case 1. See, where we have highest resistance, there it will be minimum. Highest resistance is in second. Highest resistance is in the second circuit. So heat produced will be minimum in the second case. Option C is correct. Heat produced will be minimum in the second case and maximum in the minimum minimum in the second case. Now question number 4, the resistivity does not change. Again, it is related to resistivity. The resistivity does not change if the material is changed or the temperature is changed, the shape of the resistor is changed, or both material and temperature are changed. It is related to resistivity again. Option C is correct because the resistivity will change when material changes, temperature changes, both material and temperature changes. What happens? The resistivity will change, but only when shape of the material is changed, the resistivity will not change. So option C is correct. In option C, resistivity will not change. Next question, question number 5. See here, question number 5. A cell, resistor, a key and ammeter are arranged in the circuit diagram of figure. The current recorded in the ammeter will be maximum. In which case it is maximum or maximum in 2 or maximum in 3 or same in all the cases. So this one, which one will be correct in this case? Good morning, Karantej. In which case the current recorded in the circuit will be maximum or minimum? Lena is correct. It is same in all the cases because resistance is same and there is no potential difference it is given. Resistance is only one. In all the cases it is connected in series only. So it is going to be same in all the cases. Resistance is same in all the cases. In all the 4 cases it is same. So option D is correct. Now once you go to question number 6. Question number 6. Can you see question number 6 what it is? A current in 1 ampere is drawn by a filament of an electric bulb as shown in the figure. Number of electrons passing through a cross section of the filament in 16 seconds would be roughly. So we have to find out how many number of electrons are there. Number of electrons passing through the filament. So we will be having one formula here to find out number of electrons. Number of electrons is Q by E. That is what charge by number of electrons is equal to charge by electrons. So here charge we have to find out because charge is not given. Charge is equal to I by T, I into T, because Q is equal to I is equal to Q by T. We have another formula. So Q is equal to I into T. So Q is equal to I is given 1 ampere and time is given 16 seconds. So Q is what now? 16 coulombs. Q is given 16 coulombs. So it's 10 to the power of 18 your answer, but we will check it. Q is equal to 16 coulombs. So we'll substitute the 16 coulombs here. N is equal to Q is 16 coulombs by this charge of one electron is 1.6 into 10 to the power of minus 19. Then we send this 10 to the power of 19 up. Then we get N is equal to 16 into 10 to the power of plus 19 by 1.6. And what happens if you remove this 1.6? We'll multiply 10 in the numerator and denominator. Then it will become 16 into 10 to the power of 19 into 1 we multiply, no, 10 to the power of 1 also we multiplied. So 10 to the power of 19 into 10 to the power of 1, 10 to the power of 20 by, this will become 16. So what it is going to be, 16, 16 will be cancelled. What is the answer? 10 to the power of 20. Not B, it is A. Option A is correct. 16th question, option A is correct. 10 to the power of 20 is correct. Hope you understood this. So first you find charge and then use that formula N is equal to Q by A. Then you'll get the answer. 10 to the power of 20. Now next question. Question number 7, once you try. Identify the circuit in which the electrical components have been properly connected. Which circuit they are connected properly, correctly. In the first case, voltmeter is connected in series. So voltmeter should be connected in parallel. The second case, voltmeter is connected in parallel and ammeter is connected in series. That is a proper connection. Third case, voltmeter is connected in series, ammeter is connected in parallel. That is also a wrong. Last case also, ammeter is connected in series, voltmeter is connected in parallel, but we have to see the symbols also there. We have to consider those symbols also. These two should be taken like this. Here minus and here also minus. So this is only correct option. This is here plus, here minus, it is there. These option charge terminal should not be connected like this. So option 2 is correct in this. Option B. Option B is correct. Now coming to next question. You try this question, question number 8. Which is correct in this? What is the maximum resistance which can be made using 5 resistors each of 1 by 5 ohms? Maximum resistance which can be made using 5 resistors each of 1 by 5 ohms. Maximum, how much we can get it? Harshavardhan, is it question number 8? Option B? Question number and answer you type. Option D. Lena, option D. Sai Nikhil, option D. Okay. Let's see this question. When they are connected, maximum we want, no? Maximum we want. When we connect them in the series, we will get maximum. When you connect them in the series, we get 1 by 5 plus 1 by 5 plus 1 by 5 plus 1 by 5 plus 1 by 5, which is 5 by 5. 5 by 5 is 1 ampere, 1 ohm. So maximum resistance when they are connected in series, is only 1 ohm. So option D is correct. Option D is correct. Now coming to question number 9. Try this question number 9. 1 ohm is correct. Option A, 19th option, 9th, it is question number 9. Question number 9 is option A. Okay, we will see. I told you just now, heat produced. This question is again about heat produced. If we connect both the wires one to one to the same battery, which of the two produces more heat per unit time? So we want here heat produced. Heat produced depends on what? I told you it depends on current and resistance, both even potential difference. Here what happens? It is VI relation, VI graph it is given. So for first A, if you see for A, what you have more? V is more, I is less. And for B, what happened? V is less, I is more. Second option for B, V more, V less, I more. So now heat, what I said just now, V square by R into T. So what is R here? R, it is inversely proportional to resistance, I said. When R is less, heat will be more. When R is less, heat will be more. So in these two cases, V, whenever V by I is more, V by I is more, R will be more. V by I for what it is more? V by I for A it is more. Resistance is more. The resistance value of A is more because their voltage is more, current is less. Whereas for B, R is less because voltage is less, current is more. R is less. Where R is less, their heat is more. Where R is less, their heat is more. Now tell me where you want heat, more heat to be produced. When you want more heat to be produced, less resistance should be there. Less resistance is there in wire B. So option B is correct. More heat will be produced in option B, not in A. Do you understand this? 19th option B is correct now. Next question. See question number 10. In question number 10, a cylindrical conductor of length L and uniform area cross section A has resistance R. Another conductor of length 2L and resistance R of the same material has area of cross section. See, length is increased to 2 times. Then we have to see how area to be increased changed so that resistance will be maintained same. See, we know resistance is directly proportional to L and resistance is inversely proportional to area, and you want resistance to be same. Then when you increase length, then you should also increase area so that there will be no change in the resistance. Remember this, if you want resistance to be maintained same and dimensions to be changed, then when you increase length, area also you have to increase. If you increase area, length also you have to increase. So if you increase one quantity, other quantity also you have to increase. If you decrease one quantity, other quantity also you have to decrease. So it depends on how you are changing. So 2A is correct. Option C is correct here because you want resistance to be maintained same. When resistance is to be maintained same, they both should be done in the same way. Length and area of cross section. When you increase one thing, other thing also you have to increase. When you decrease one thing, other thing also you have to decrease. So option C is correct. Question number 10. Now question number 11. Question number 11. Once you see question number 11, if the current I through a resistance is increased by 100%, the increase in power dissipated will be power. When current is increased, how power is changed, we have to find out. Do you all remember the power formula? Power is equal to I square R. Power is equal to I square R. Because we want the relation current I is given, that is unchanged. Current I through the resistor is increased. So current we have to take consideration and R. So now R is increased. If the current through the resistor is increased, current is increased. What is increased? Current is increased. So what happens here? If you increase current, what happens? 100% it is increased. So I1, if you take I2 will be 2I, doubled. 100% means it will be doubled. Current will be doubled. So now in the second case, P2, in the second case, it is going to be 2I whole square into R, which is 4I square R, which is 4 times P1. P2 is 4 times P1. So P2, how many times it is increased? Power in the second case is increased by 4 times. So now how much increase? Change in the power, delta P, means what change in the power is? P2 minus P1. P2 minus P1 is 4 times power minus 1 time power, which is 3 times power. 3 times it is increased. Initially power is P I square R, but after you are changing the current 100%, that is doubled, then it becomes 4I square R, means what, 4 into power 1 again. So what we get, 4P minus P. The increase change in the current is 4 times. So it is 3 times increased. When it is 3 times increased, increase percentage will be 300%. When it is increased 3 times, increase percentage will be 300%. Hope you understood this. Increased percentage is 300%. So next, let's see next one. This one, question number 12. See the figure carefully, observe the figure carefully and find out what are the readings, what are the ammeter and voltmeter readings. Which option is correct? Voltmeter and ammeter readings. You have to see question careful, that figure you have to observe carefully. Voltmeter is after 2 it is, right? After 2 before 3. After 2 before 3. That is the voltmeter reading. And what is the ammeter reading? Between 0.2 and 0.4. Between 0.2 and 0.4. Did you find out what correct option it is? Option A, cynical, correct. So 2.1 volt and 0.3 ampere. 2.1 volt and 0.3 ampere is correct. First option it is showing correct. Correct. Next one, question number 11. Question number 13. Two resistors are shown in the above figure. When it connected to a battery will have. What happens if these two resistors are connected to battery? What happens? Read the options and select the first correct option. Read all the four options and select the correct option. One is 2 ohms and other is 4 ohms. What happens here? Same current flow through them when connected in parallel. Same current flow through them when they are connected in series. Same potential difference across them when connected in series. Different potential differences across them when they are connected in parallel. So here you have to know this point when they are connected in series connection, same I, different V, parallel connection, same V, different I. Now decide what is correct option there. Same current flowing through them when they are connected in parallel. That is wrong. When they are connected in parallel, current will be divided. When they are connected in parallel, current will be divided. Same current flow through them when they are connected in series. Option B is correct. Option B is correct because when they are connected in series, current will be same. When they are connected in series, voltage, potential difference will be divided. When they are connected in parallel, potential difference will be same. So option B is correct. I told you there, when they are connected in series, current will be same. So option B is correct in this case. So you all have idea about when you do derivation of R is equal to R1 plus R2 plus R3, and one more derivation of 1 by R plus 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. We have that derivation, in that we follow this, how they are connected in which series. Now here, question number 14. In an electric circuit, two resistors of 2 ohms and 4 ohms respectively are connected in series to a 6-volt battery. The heat dissipated by 4 ohms resistors in 5 seconds will be. You have to find out heat through 4 ohms. Time is given 5 seconds. We have formula H is equal to I square RT. We have formula H is equal to I square RT. What is R here? It is given 4 ohms. What is time here? It is given 5 seconds. What we have to find out? We have to find out I what it is. And in series connection, current is same. In series connection, current through 2 ohms and current through 4 ohms both are same. So you can find out current here. So we know current is equal to potential difference by R. So I is equal to V 6 volt by current resistance is what? 2 ohms and 4 ohms are connected in series. When they are connected in series, 6 ohms by 6 volts. 6 ohm by 6 volt means what? It is 1 ampere. Current is 1 ampere. So you have to find out now what is this I. I is equal to 1 square into resistance is 4 and time is 5. 1 into 4 into 5. So what is heat dissipated through 4 ohms? What is the heat dissipated to 4 ohms? Current is 1 ampere. Heat is 1 into 4 into 5. 20 joules. It is 20 joules. Option C is correct. First you have to find out what is current. Already you have resistance and time. This current, resistance and time you substitute in formula. We get heat produced. Right. Now let's try question number 15. When a 4-volt battery is connected across unknown resistor, there is a current of 100 milliamperes in the circuit. The value of resistance of the resistor is. So you just find out resistance because potential difference is given, current is given, you have to find out resistance what it is. What is resistance formula? R is equal to V by I. R is equal to V by I. So V is given 4 volt by I is given 100 milliamperes. I told you milli means what? Milli means 10 to the power of minus 3. So it is 100 into 10 to the power of minus 3 amperes. So it is going to be 4 into 10 to the power of plus 3 by 100. This 10 to the power of minus 3, if it goes up, it will become positive. 10 to the power of 3 by 100. So what it is? 10 to the power of 3, 4 into 10 to the power of 3 is 4000 by 100. So what it is? 40 ohms. R is equal to 40 ohms. Which option is correct? R is equal to 40 ohms. Option B is correct. Milli means 10 to the power of minus 3. When you go it up, when you send this up, become 10 to the power of plus 3. And 4 into 10 to the power of 3, 4000 by 100 is down. So it is 40 ohms. Now next see question number 16. The length of the wire is increased, its resistivity. Again question is on resistivity. What happens to resistivity? The length is increased, does resistivity changes? It's not resistance, ma, it is resistivity. Question number 16 I am talking about. Question number 16, we already discussed before. When dimensions are changed, resistivity does not change. Resistivity depends only on nature of the material and the temperature. Now here length is increased, so resistivity does not change, it remains same. It remains same. So option C is correct. Question number 16, resistivity does not depend on length. So option C, it remains same. Charantej, it is not B. It remains same because it is resistivity. If it is resistor, it is directly proportional. It increases. When length increases, resistance also increases, but resistivity will not change. Now, question number 17. The current in a wire depends on only the potential difference applied, only on the resistance of the wire, both A and B, volume of conductor. It depends on both what potential difference applied and the resistance. R is equal to V is equal to I into R. So it depends on both potential difference and resistance. So option C is correct, both A and B. Current depends on both. Now let's see question number 18. See, it may increase or decrease depends on the temperature. Okay. Question number 18. The temperature increases. As temperature increases, ratio of resistivity to conductivity, it may increase or decrease depends on the temperature. It vary. So option D is correct. Question number 19. The product of resistivity and conductivity of a cylindrical conductor depend on resistivity and conductivity. Both depends on it does not the product of resistivity and conductivity of cylindrical conductor depends on temperature and material both. It is given none of these. Yes, none of these because they both are reciprocals, opposite quantities. Now, once you see question number 20, the graph of one I on y-axis and v on x-axis is found to be a straight line. The slope of the line gives. What it gives slope of the line? Graph is given like this. So here I is on y-axis and v is on x-axis. The slope of the line gives us, see like this we draw the line now. You know what is the slope of a line? Slope of a line is its vertical distance by horizontal distance. Slope of a line, you remember, slope of a line is nothing but it is vertical distance by horizontal distance. Vertical distance is what here? I. Horizontal distance is what? V. So he is asking ratio of I by V. This is what slope now. You remember slope means, I will write here formula. Slope of a line is y by x. Change in y by change in x. So it is y by x. Y by x means here it is I by V. I by V is what? V by I is resistance. We know V by I is resistance. Then I by V is reciprocal of resistance. I by V is reciprocal of resistance. So this is option C correct. Hope you understood this to hear all these questions. Now some assertion and reasoning are there. Let's see what are these assertion and reasoning questions. The first question is what? The connecting wires are made up of copper. The electrical conductivity of copper is high. Both are true. Conducting wires made up of copper is true, and because it is having high conductivity is also true. So assertion is true, reason is true, and reason is the correct explanation of assertion. Next, one minute. Second question. When the length of wire is doubled, then the resistance also get doubled. Is it true? Second question, once you try to answer, length of wire is doubled, resistance is also doubled. Is that true? Length of wire and resistance both increases. If they increases, both are increased. If they decrease, both are decreased. One second. Yes. If they are decreased, both are decreased. So question number two also true. When length of the wire is doubled, resistance also gets doubled. True. And resistance is directly proportional to the length. That is true. And reason is the correct explanation of assertion. Now, question number 23. The 200-watt bulb glow the more brightness than 100-watt bulb. 200-watt bulbs glow with more brightness than 100-watt bulbs parallel. Yeah, true. When power is more, it glows more. The 100-watt bulb has more resistance than 200-watt bulb. That is also true. Assertion is true, reason is true, and reason is the correct explanation of assertion. Next one, I told you just now, heat produced or power produced will be more. It will be inversely proportional to resistance. Now, question number 24, heat heater wire must have high resistance. Will be the high melting point. Yes, heating wire should have high resistance to produce more heat and high melting point also so that it will not melt. If the resistance is high, electrical conductivity will be less. That is true. Here also assertion is true, reason is correct explanation of assertion. Next question number 25. A fuse wire is always connected in parallel with the main line. Is it true? How fuse wire will be connected? How we connect fuse wire? Fuse wire will be connected in series always. Remember, very important. Fuse wire will be connected in series always so that when it is broken, the remaining the current supply will be stopped. So question number 25, assertion is false because it will be connected in series, and reason is true. If a current larger than the specified value flows through the circuit, fuse wire will melt. So option D is correct. Assertion is false, reason is true. 26. When a battery is short circuited, the terminal voltage is 0. In the situation of short circuit, the current is 0. Here assertion is true, reason is false, because terminal voltage is 0, but the current will be high. Question number 26, option C is correct. Question number 27. All electric devices shown in the circuit are ideal. Diagram is given here. All electric devices shown in electric circuit are ideal. The reading ammeter A is 0 and voltmeter is E. Current is 0, voltmeter is E. An ideal voltmeter draws almost no current due to very large resistance, and hence V and I will read 0. Here reason is true, assertion is false. This is option D. Question number 27. Once you see question number 28, if rho 1 and rho 2 be the resistivity of the materials of two resistors has same dimensions of resistance R1 and R2 respectively. If R1 is greater than R2, then rho 1 is greater than rho 2. Not compulsory. Same dimensions. Okay, if dimensions are same, if resistivity is same, if resistance is resistivity and resistance will be in same manner. Okay, if dimensions are same, if they are different dimensions, resistance will be changed. Even resistivity will not be changed, but resistance is changed. Because they mention same dimensions, assertion is true and reason is also true. Next, question number 9. The product of resistivity and conductivity of a conductor depends on the nature of the conductor. Assertion is true because each of resistivity and conductivity depends on the material of the conductor. 19th also option A. 20th, fuse wire must be having high resistance and melting point of the fuse wire is less. Assertion is true and reason is true, but reason is not the correct explanation of assertion because melting point is low, it will not have high resistance. So we should have high resistance, we should have low melting point, but because you are having low melting point, resistance is not high. So A is true, B is true, but B is not correct explanation of A. So this is option A. Option B. Here some skill based questions it seems here. First question, why don't we use series arrangement of electrical appliances like bulb, television, fan and other domestic circuits? What happens if we connect all these domestical appliances in series? What happens? Do we connect them in series or parallel? All the electrical appliances, TV, fan and everything, we connect them in series, not in the parallel. What happens if we connect them in series? We cannot use them individually. If you switch off one device, all the remaining devices will be switched off. If you switch on one device, all the remaining devices will be switched on. So that in that way we cannot use it, no. So all the electrical appliances should be connected in parallel, not in series. The second question also same. What happens if they are connected in series? Why do we consider tungsten as a suitable material for making a filament of bulb? Why do we use tungsten only to make filament of a bulb? Because tungsten has high resistance and high melting point. We want material such a way that should not melt and it should produce heat. So by that heat, later when it produces more heat, it will burn, it will produce light. So what happens? It should have high melting point, high resistance, high melting and high resistance. Due to its high resistance and high melting point, tungsten is used as a filament. How do you verify that resistance of a conductor is inversely proportional to the cross-sectional area of a conductor at constant temperature and length of the conductor? So how do we verify that resistance of a conductor is inversely proportional to area? We have factors affecting the resistance. One is length is directly proportional to resistance, or resistance is directly proportional to length of the conductor. One more is area of cross section is inversely proportional to resistance is inversely proportional to area of cross section. How do we prove that resistance is inversely proportional to area of cross section? We will be having one circuit arrangement. In that, once we use potential difference and current, resistance, all will be there. One conductor we connect. We'll be having ammeter in series and voltmeter in parallel along with that conductor. Then in that we will measure every time current and voltage, how they are. So here what we do, one time we use one conductor with less amount of thickness, and one more we measure the values, and one more time what we do, we connect one more conductor which is having more thickness comparatively the previous one. In both the cases, we will observe how measurements are going to be current and voltage. Based on that, we decide, we find out the resistance in both the cases. Then in which case resistance is more, in which case resistance is less, we can find out. So based on that, we can decide how it is being changed. Circuit, in that circuit, one time a conductor with less thickness, second time a conductor with increased thickness. In both the cases, we measure the V and I values. Based on V and I values, we can find out the resistance value, in which case it is more, in which case it is less. And your observation will be, when you are having a resistance of less thickness, it will show more resistance. A resistance of high thickness, it will show uh, more less resistance. High thickness, more less resistance. Less thickness, high resistance. It is inversely proportional, no? So resistance and thickness will be opposite manner. Next question. Suppose that you have three resistors, each of value 30 ohms. How many resistors can you obtain by various combinations of three resistors? Draw diagrams in support of your answer. Three resistances are given. How many different kinds of resistances we can produce? One case, you can connect all of them in series, 30 plus 30 plus 30 plus 30, 120 maximum resistance. And one more case, we can arrange all of them in parallel, 1 by 30, 1 by 30, 1 by 30, 1 by 30, which is 4 by 30. They are in parallel. Later it will become 30 by 4. That is what parallel connection, where we get minimum resistance. One more, you can arrange them two in series, and the third one is parallel along with these two. Two resistors in series, and the third one parallel. One more, last one, we can connect the first two in parallel, and that can be connected along with third one series. In this way, we can arrange them. Two series, one is parallel, and the next one two parallel along with series. So four ways we can arrange, and four different resistors we can obtain. You can draw those diagrams also. Diagrammatically, we can represent them, how we connect them. Now, question number 6. Suppose that you have three resistors, each of, that is only, no, next one, a uniform wire of resistance 100 ohms is melted and recast into a wire of length double that of original. what would be the resistance of the new wire formed? Initially it was 100 ohms and it is melted and that length was doubled. When length is doubled, what happens? When length is doubled, thickness will be decreased. Same wire we are using, no? Same wire melted and recast into length doubled. When length is doubled, area will be half. If area is half and length is double, it will be increased 4 times. 400 ohms. If the resistance of your body is 1 lakh ohm, what would be the current flow in your body when you touch the terminals of 12-volt battery? Current is equal to what? V by I. V by I. So 12 by 10 to the power of 5. 12 by 10 to the power of 5. So it is going to be 12 into 10 to the power of minus 5. 12 into 10 to the power of minus 5 amperes. 12 into 10 to the power of minus 5 amperes. You can find out like that. Means what? 1200 milliamperes. 1200 milliamperes. What is the lowest resistance that can be obtained by 4 coils of resistances? Whenever you want lowest resistances, what we do? We connect them in parallel. We connect them in parallel so that we get 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. LCM is 24. Then it is 6 plus 3 plus 2 plus 1 by 24. So what it is? 12 by 24. This is 1 by R. Then what is R? R is equal to 24 by 12. So 2 ohms. So when you connect them in parallel, we get 2 ohms resistance. If a heater is resistance of 100 ohms is connected to the same source instead of the bulb, calculate the current drawn by the heater. How much current will how much current will an electric bulb of resistance 1100 draw from 220 volt source? So first we can find out current directly 220 by 1100. If a heater of resistance 100 ohms, first 220 by 1100 and then next 220 by 100. In both the cases you have to find out the current. That's it. Okay. Remaining problems after this 10th question, remaining questions 11th, 12th, 13th in the next session we will discuss. Hope this was helpful to you. I will send this PDF also in the group. You can go through, you can work on it. In this all are there, not only electricity, all 4 topics of physics are there, like these questions, objective, short answer type and long answer type. We can go through these question and answers and try to be perfect in science related questions. All the 3, physics, chemistry, biology, today I will send you. If possible, take the printout and practice. Okay. In case study questions are also there. Case study questions are also there. Take the prints and practice. Okay. Right. Thank you. And whatever doubts you have, you can come to me in the evening session for clarification. Thank you.